For this video, I want to cover indirect recursion. Now, what is indirect recursion? Indirect recursion is when there is more than one function and they call each other in a cyclical manner. So for example, if I have function A and function B, function A will call function B, and then function B will call function A, and then function A will call function B again, and then function B will call function A until it reaches the base case, or until they reach the base case, or one of the functions. This results in the original function being called again. Indirect recursion is also referred to as mutual recursion because function A and function B, or the functions, depend on one another. Okay, let's go over an example. So on the left hand side, I've created two functions, indirect recursion A and indirect recursion B. On the blue side, on the right hand side, I have our main function. And main calls indirect recursion with an argument of 5. I went ahead and created an activation record for main on our stack frame. Using the stack frame to trace our code, I am going to abbreviate indirect recursion A function to IRA and indirect recursion B function to IRB. Again, in our main function, indirect recursion A was called with an argument of 5. And every time a function is called, an activation record is created. So we go to IRA, so indirect recursion A, with a data of 5. On line 28, the compiler checks if the data entered, and in this case 5, is greater than 0. That is a true statement, so we enter the if condition. And on line 30, data is printed. And on our stack frame, I'm going to use P to abbreviate print, and also write the output on this left-hand corner. And then we go into 31, and the compiler checks to see if our data mod 2 is 0. So we're checking to see if the remainder is 0. So basically, if the remainder is 0, we know that we have an even number. If the remainder is not 0, then we know that we have an odd number. In this case, we know that 5 mod 2 is not 0, so it's going to go to line 34 and print odd right next to 5. And then we go to line 36, and this is where the indirect recursion occurs. It calls indirect recursion B, so we have two print statement, and then it calls indirect recursion B with data -1, and 5 minus 1 will be 4. And every time a function is called, an activation record is created. So we have one for IRB4. So the compiler goes to line 40 to enter the function, and on line 42 it checks the condition of is 4 greater than 0, and that is a true statement. So on line 44 it prints out the data. The compiler then goes to line 45 and it checks to see if 4 mod 2 equals 0 or is 0, and in this case it does. And so 46 we print out even. And then we go directly to line 50 and we call indirect recursion A with data -1. So IRA, data -1, 4 minus 1 will be 3. And again, an activation record is created for IRA with an argument of 3. So we go to line 26 and enter the function. And on line 28, the compiler checks to see if 3 is greater than 0. And that is a true statement. So on line 30, we print the data. And then it checks on line 31 if 3 mod 2 equals 0. Well, this is a false statement, and so it prints odd. We then go to line 36, and indirect recursion B is called with data -1. So IRB, and 3 minus 1 will be 2. Once again, every time a recursive function is called, an activation record is created. So here we have one for IRB with an argument of 2. So we go to line 40 and enter the function. The compiler checks on line 42, is 2 greater than 0? The answer is yes. So it goes to line 44 and it prints the data. Then it goes to line 45, is 2 mod 2 equals 0? Yes, it does, so it prints even. It then goes to line 50 and calls indirect recursion A, IRA, and 2 minus 1 is 1. And so an activation record is created for IRA with an argument of 1. So we go to line 26, and on line 26 it checks. The condition is 1 greater than 0. That is a true statement, so we enter the if statement. On line 30, the data is printed. And then on line 31, the compiler checks. It's 1 mod 2 equals 0, and that's false. And so we go to line 34 to print odd. We then go to line 36, or the compiler goes to line 36 and calls indirect recursion B with data minus 1, so IRB0. And again, an activation record is created in a stack frame for IRB0. So we go to line 40 and enter IRB. And on line 42, the compiler checks to see if 0 is greater than 0. And the answer is false. And so we don't enter the if statement. That completes the function, and IRB is popped off the stack frame. The control then goes back to IRA1, and there's nothing left to do with IRA. And so that function is popped off the stack frame. The control then goes back to IRB2, and it resumes after line 51, and there's no other task. And so IRB is popped off the stack frame. The control then returns to IRA3, and that resumes back on line 37, and there's no other task left, and so that function is completed, and IRA3 is popped off the stack frame. The control then goes back to IRB4, and it resumes on line 51, or after line 51, and there's no other task left to do on that function, and so that function is completed, and IRB4 is popped off the stack frame. The control then returns to IRA5, and that resumes after line 37, and there's no other task left to do, and so IRA5 is popped off the stack frame, where the control goes back to main. And the output should be 5 odd, 4 even, 3 odd, 2 even, and 1 odd. And let me compile this. And there it is. 5 odd, 4 even, 3 odd, 2 even, and 1 odd. Now let's change our argument to 6, and let me compile and run that. And there it is. 6 even, 5 odd, 4 even, 3 odd, 2 even, and 1 odd. So basically our indirect recursions are mutually relying on each other to do a countdown and to print odd and even. Now let's use a tree to trace our indirect recursion function. In main, indirect recursion A with an argument of 5 is called. The compiler jumps to line 26, and on line 28 it checks, is 5 greater than 0? The answer is yes, so it prints the data. And then it checks. If the data of mod 2 is 0, then it prints even. Otherwise it prints odd, and in this case it's not a mod 2 equals 0, so it's going to print even. And I'll just abbreviate even for E. It then calls indirect recursion B with data minus 1, so that makes it IRB4. We then go to line 40, and on line 42 the compiler checks, is 4 greater than 0? And the answer is yes. So it goes inside the if statement, and then on line 44 it prints the data. And I'm sorry, let me backtrack. On IRA5, 5 mod 2 does not equal 0, so this makes it odd. Okay, so back to IRB, and so it prints the data on line 44, and then on line 45 it checks 4 mod 2 equals 0. That is a true statement, so it prints even. And then it goes to line 50 and calls indirect recursion A, so IRA, 4 minus 1, which gives us 3. And so we go to line 26 to enter the function, and on line 28 it checks, is 3 greater than 0? Yes. And so we enter the if statement, and 3 is printed. We then go to line 31 and check if 3 mod 2 equals 0. Well, that is false, and so odd is printed. The compiler then goes to line 36 where indirect recursion B with 3 minus 1 is called. We then go to line 40, and the compiler checks. On line 42 is 2 greater than 0. That is a true statement, and on line 44 it prints out 2. Then it goes to line 45, Is 2 mod 2 equals 0? The answer is yes, so it prints out even. And then it goes to line 50 and it calls indirect recursion A with 2 minus 1, which is 1. We then go to line 26 and enter the function, and the compiler checks on line 28 is 1 greater than 0. That is a true statement. The compiler enters the if statement and prints the data. And then on line 31 is 1 mod 2 equals 0. Well, that is false, and so it prints odd. The compiler then goes to line 36 and calls indirect recursion B with data minus 1, so that's IRB0. The compiler then enters the function on line 40, and on line 42 it checks is 0 greater than 0. The answer is false. So the compiler never enters the if statement and this function is completed. And let me trace this with a different color so that I can demonstrate the output. So you start on the left hand side and we enter IRA 5, and then 5-0 is printed. And then we enter IRB 4 and 4-E is printed. And then we enter IRA 3 and 3-O is printed. And then we enter IRB 2 and 2-E is printed. And then we enter IRA 1 and 1-O is printed. And then we enter IRB 0 and nothing is printed. So we return back to IRA 1 and there's nothing left to do with that function. And so that function is completed. The control returns to IRB 2. There's nothing left to do in that function, so that function is completed. The control returns to IRA 3. There's nothing left to do, so that function is completed. The control returns to IRB 4. There's nothing left to do, so that function is completed. And the control returns to IRA 5, and there's nothing left to do, so that function is completed. The control returns back to main. So our output is 5 odd, 4 even, 3 odd, 2 even, and 1 odd. There it is. And that explains indirect recursion. In summary, indirect recursions are more than one functions that call one another in a cyclical manner, and this eventually results in the original function being called again. And indirect recursion is also referred to as mutual recursion because the functions depend on one another. Thank you for watching.